Hey guys, welcome to another online math class. This video will be about linear programming, and by the end of this lesson we should understand the terms objective functions and constraints, be able to use the corner point principle, and finally be able to find the maximum and minimum value of an objective function. Let's just pause the video here and take a couple of minutes to write these down. So starting off with our key terms, the terms objective functions and constraints. An objective function is a quantity that you are trying to make as large or as small as possible. So some examples of this. Something you're trying to make as large as possible might be profits. So every company will always be trying to make their profits as large as possible. And an example of trying to make something as small as possible might be the resources a company uses, or maybe the amount of resources used in making a product. So usually companies will always be trying to reduce the amount of resources or materials used, one, to save costs, and two, to protect the environment. However, when going for these targets, there will always be some limiting factors that affect the amount of profits or resources used. A limiting factor for the maximum profit might be the number of seats at a restaurant, and a limiting factor for reducing the amount of resources used might be the minimum amount of resources required to create a product. So think about baking a cake. Eventually you'll come to a point where you can't take out any more ingredients. And these limiting factors are called constraints. So this is where linear programming comes in. So linear programming pretty much tries to find out how much you can maximize or minimize a linear quantity whilst taking into account the limiting factors or constraints. And in order to do this, we need to go back to our understanding of feasible regions. And to help us achieve this, we've got something called the corner point principle. So this principle states that the maximum or minimum value of a linear objective function will occur at one of the corners of the feasible region. So if you think about last lesson, we had to go finding the different corner points in a feasible region. So this is why the corner points are important, because at the corner points, you're either going to find the maximum or the minimum values. So keeping that in mind, let's have a go at some example questions here. So this question says, find the maximum value of the objective function p equals 2x plus 3y, subject to the constraints right below there, as shown by the feasible region opposite. So in this case, you don't have to graph it yourself. They've already given you the graph. And we just need to use the coordinates of the different corners to help us with this question. So when solving questions like this, making a table like this will help you out. So we're going to start off by writing our objective function in there, and that is p equals 2x plus 3y. So that's just that formula up the top there. And now we're going to list our different coordinates in the corner region. So my first one I can see in the corner is going to be 0, 0. That's my first set of coordinates. Next one, b, is going to be 0, 6. Third one, C, is going to be 5, 3 right there. And last one, D, is going to be 8, 0. So these are all the points that are in the corner of the feasible region. So feasible region, you can see there, that's one corner, that's the second, that's the third, and that's the fourth. Once you got that, we're going to substitute these values into there. So in this case, both my x and y values are 0. So that's just going to give me p equals 2 times 0 plus 3 times 0, which equals 0. Next one, substitute them in again. X is 0, y is going to be 6. That's going to give me 2 times 0 plus 3 times 6. That's going to give me a value of 18. Third one, same thing, just substitute those in. This one's 5, 3. That's going to give me 2 times 5 plus 3 times 3. And that will give you a value of 19. And last one, that's x is 8 and y is 0. So that gives me p equals 2 times 8 plus 3 times 0 gives you a value of 16. So going back to the question, this says find the maximum value of the objective function, p equals 2x plus 3y. So if you have a look, that's pretty much asking which one of these four gives you the highest value of p. And in this case, it will be the coordinates 5, 3. So this one here. So our final answer will be the maximum value of p. I'll just write that in. Of p equals 19 occurs when x equals 5 and y equals 3. So you might want to write that down into your books just so you have a sample answer to go off. Alright, let's try another question here. This time it says find the minimum value of the objective function c equals 5x plus 2y subject to these constraints. So once again, it's very similar to the question before, so I'm going to need one of these tables again. So it's got my feasible region for us again, so we don't need to worry about graphing it. That's my first corner, that's the second, and that's the third. There's only 3 corners this time. Alright, to start off by writing your objective function in there, so that's c equals 5x plus 2y. Now let's list the 3 coordinates. My first one, a, is going to be 0, 9. Next one's 4, 3. And last one, c, is 10, 0. Alright, now we're going to substitute these values in. So that's when x is 0, y is 9, so that gives me c equals 5 times 0 plus 2 times 9, that gives you a value of 18. Next one, that's 4, 3. So I'm going to substitute that in, c equals 5 times 4 plus 2 times 3, that gives me 20 plus 6, which is 26. And last one, c equals 5 times 10 plus 2 times 0, which gives you a value of 50. Alright, so going back to the question, this time we're after the minimum value. So they're probably trying to minimize something here. So therefore our answer is going to be at 0, 9. So this one, that's our smallest value for C. So we can say something like, therefore the minimum value of C equals 18 is found at x equals 0 and y equals 9. Otherwise, that brings us to the end of this video. Hopefully you guys have a better understanding of the terms objective functions and constraints now, can use the corner point principle, and finally can find the maximum and minimum values of an objective function. Thank you guys for watching, and I'll see you guys all back online.